In one of my last videos, you requested a step-by-step explanation of how I built CondoGPT, an intelligent assistant for analyzing real estate data in Miami. I then released a video showing how I designed the architecture of AI and backend development projects. In this video, I'm going to show you how I develop CondoGPT so that you can learn LangChain, LangGraph agents, vector databases, and start your journey on becoming an AI engineer yourself. So let's get started. First up, we're going to go on the CondoGPT repository page, link in the description, and we're going to download the sample DB. So we're going to start a new VS Code project. So we're going to start a new file, call it main.py. Yeah, we'll save it right there. Great. And we need to start a virtual environment. So Control-Shift-P, Python, create environment. We're going to use VNV. Choose any interpreter, really. Let that do its thing. And we're actually going to follow the instructions on the repository. So set up the environment and let's open the terminal by pressing the play icon. So we need to set up Postgres. I'm assuming you already have PSQL installed on your computer. Depends on what system you're on. We're going to start by logging into PSQL as a super user. And these instructions, I'm assuming you're using Linux. If you're using Windows, God forbid, or Mac, you can just Google those instructions. And we're going to enter our password here. Now we're signed into PSQL. Excellent. So we're going to copy this command. So what we're doing here is we're creating a database called CondoGPT, setting up a user called read-only user with the password. In production, use a safer password, s'il vous plaît. We're granting access to the read-only user, and we're basically making sure the user has select permissions on all tables and nothing else. Because we're going to be using an LLM to generate SQL commands, and I don't know about you guys, but I don't trust ChatGPT to not generate a command called drop table, relevant xkcd coming up. So we're going to execute this, and great. So now we have our Postgres user and database set up. If you have any errors, it might help that you type in the commands line by line rather than copy and pasting the whole bunch like I did. So we're going to go into our environment, bin, activate, and here we're going to put our environment variables. So here are the environment variables. The OpenAI key, I'm not going to give you mine. Sorry, I don't care if you're a subscriber. You're not sending a bunch of tokens to my credit card. Same thing with Google Places API key. Don't need to worry about that right away. And the rest, a Flask secret just needs to be any string. As you can see, not really a super secret key. Ideally, you'd go on something like here you go, you generate a super secret key, but honestly, I don't really care for this project since it's not running in production. And here you're gonna set the Postgres credentials that we just set up. So read-only user, password, the port is by default 5432. So you can just put that there. We haven't really done anything to alter that. And the name of the database, CondoGPT. Great, so make sure you save that. And now we are going to go into the terminal, type in deactivate to deactivate the environment. And now we're going to do dots. We're dots.vnv bin activate to run the activation script. And we just reactivated our environment. And we can test that the variables were set by echoing pgport, for example, or pgdb, CondoGPT2. Okay, great. So the environment variables are loaded and working. Excellent. Now we can finally start to program. Also, remember the sample DB we downloaded? Well, I almost forgot. We actually have to load it into the database we just created. So just make sure you're in the same directory as your sample db.sql file. And we're going to run this command. And this command will load the contents of the .sql file into your Postgres database. So you're going to have the real estate sales data and information, everything you need, all the data you need for this project. Now I already have the data loaded into my database, so I'm not going to run this command, but you should have no problem in doing so. So next up, we need to install the dependencies. And we're going to enter the requirements.txt and basically create a file here called requirements.txt, paste in, and you'll see there's a lot of requirements here, especially since we're using Flask to serve the web app. But really the most important ones here are LangChain, LangChain Community, LangChain OpenAI, LangGraph. That's kind of like the root of the application. The rest are just add-ons to make it interact with different tools. But we're going to pip install -r requirements.txt. Oh, I put my file in the wrong directory. So now we're going to pip install -r requirements.txt, and that's going to install all the dependencies to our environment. So let's make sure our OpenAI API key works, and we can actually send calls to the LLM. So I just put together this very simple script for checking that. So here we're just going to check for the OpenAI API key, which we set up in our virtual environment. And here we're initializing the chat OpenAI with a couple of parameters. This is just testing, so I'm not going to go through it all, but basically you're a helpful assistant that translates English to Portuguese. Translate the user sentence. And we're going to run this. Eu amo programar. If you speak Portuguese, you'll know that that is the correct translation. So it works. Great. Excellent. We can just get rid of this. And now let's develop CondoGPT. So the first thing we need to do is basically set up our Postgres credentials. So just to make it easier and more readable, I'm going to import OS first. I'm just going to store these in actual constants. Postgres user equals to os.get-env pg user. And let's see, what do we have here? We have password, port, and db. Yeah, so we're basically loading in our environment variables here into Python variables, just to make it a bit more readable. And next up, we're going to create our PostgreSQL connection string. So here we're using an f string, which in Python is a template literal, if we're speaking JavaScript here, basically a way that you can inject Python variables into strings. So Postgres user goes here, Postgres password at localhost, because we're running the Postgres server locally at this point. Again, if this was a production app, you would change that. And Postgres DB. And you may be wondering, okay, well, what if I'm actually using this in a production environment? Well, you need to decide how are you hosting your database server. If you're using a database as a service, for example, if you use Render AWS, you can set up in a SQL database there. Well, you're going to get a URI that you can connect to, which will be this connection string. If you're hosting on a Droplet on DigitalOcean where everything's within the same server, you can still go through the local host route, but it will probably look a bit different. But 9 times out of 10, in production, you will get your connection string already. And so we are going to first import from LangChain community.utilities, the SQL database, import the SQL database tool that they have. And we're going to initialize our DB with a SQL database, and it has this nice method called from URI. So it's going to initialize the database using our connection string. Great. Likewise, we're going to import from LangChain _OpenAI import chat OpenAI. And then we can initialize our LLM as chat OpenAI. And here we choose the model, which I always go with GPT-4o mini. And now we need to write our SQL prefix. So this is essentially human instructions on how the program should interact with all the tools that you provide it. So you're feeding this into the LLM so that the LLM can decide how to use the SQL database, how to use the Google Maps tool, or all the other tools that we're gonna write in just a second. So this is essentially the brain of the application. Writing the SQL prefix or prompt engineering in general might just be the hardest part of AI engineering. So it takes a lot of time, trial and error to come to a prefix that actually works. I have one that works well enough, and I'm just going to go through line by line my process, how I got to here. But honestly, it's a lot of trial and error, and it's not really something I can teach out. I can just give you general tips. But this is, like I said, the brain of the application. So spend a lot of time making sure that this part is right. So we start with a very basic description of what the app is. You're an agent designed to interact with an SQL database. So given an input question, generate a Postgres query to run, then look at the results and try to answer the question essentially. For memory efficiency, we're never going to query for all the columns, just the ones that are relevant to the question, and remind it that it has access to other tools as well. Here we're piping in the table names that it has access to, because you might have a large database where a lot of tables don't really make sense for the LLM to use. Well, then this is how you exclude those. And what you'll find when prompt engineering is you have to be very specific, explicit, and repeat yourself. So only use the below tools. Only use the information returned by the tools to construct your final answer. This is to prevent hallucinations and all that, which if you're not extremely explicit like this, it unfortunately happens a lot. Double check the query. Do not make any DML statements. Do not alter the database. This is again why we set up a read-only Postgres user, because we can't trust the LLM to actually abide by these instructions 100%. So always make sure that your database is secure. To start, you should always look at the tables in the database to see what you can query. Do not skip this step, again being explicit again. Then query the schema of the most relevant tables. In here, this is kind of just a glossary, because when we query sales, well, this is how the sales table looks like in the database that I have, because it was generated by Django. So just try to be nice to the LLM and, spoon feed it this stuff so it doesn't have to spend time figuring this out manually. Buildings or condo buildings in the prompt will refer to this table, etc. And what you'll find is when you don't specify like this, you're just going to get wrong data handed to you, and that's kind of how you figure out what to specify and what you don't. So you just build on it consecutively until it works, essentially. Also, I'm not like a PhD in prompt engineering. Maybe there's a better workflow for doing this. Honestly, this is what works for me, so sue me. Here's an interesting example, because you can query on addresses, and let's say the address has avenue. Well, if you put in these commands, it will make sure that if you put avenue or if you put av, it's going to query both avenue and av, because in the database, some addresses have av, some have avenue, some have street, some have st. You have to really understand the data you're dealing with. So wherever you get your data from, Kaggle, I recommend you can go through and analyze the data and see how it's structured so you can figure out what rules you need to set up here. And you can also give a nice explanation of why this is important, which will also help the LLM to understand why to do it. Remember, you're kind of interacting with something that's been trained on data. Data is generated from the human brain, and it's trained to work as closely to the human brain as possible. So just like talking to a human, if you really emphasize the importance of certain things, it can help you have better outcomes. I have some other code for the tools, but I'm going to go through those when we actually write the tools. So if prompt about the holding period for a building, this is kind of just like a neat thing that I added, because in real estate, looking at a holding period is very interesting, but that's not something an LLM will understand right off the bat. So here's me pretty much writing a liaison from the business or the real estate world into the technical world, basically translating what a holding period is and how to perform holding period analysis. And that's why we're piping in a holding period boilerplate. And if you look in the repo, I have a boilerplate up high. And let's create boilerplate.py. Again, I'll have some stuff here that's not relevant yet because we haven't gone through the tools. But for holding period boilerplate, I actually wrote the SQL query needed to get the data required for this specific feature because it's a bit advanced and more intricate. So it helps a lot by giving it a sample query. So this is a query for the holding period. This is for 2-bedroom holding period. So the program can see how it differs between what type of apartment units we are trying to get the holding period for. And if you're curious, the holding period is basically for a particular apartment between its last sale to the sale before that. So how long the previous owner held on to the unit. This is very interesting to know because if a holding period is very long, then maybe the people that buy the units are very satisfied there. It's appreciating greatly. If the holding period is shorter, it can mean a lot of things. Maybe a lot of people are dissatisfied, or maybe it's great for short-term investment. There's a lot of things that a holding period can tell you. And here I specify, here's an example with 2 bedrooms so that you know how to get it for a specific type of unit. And here I'm explicitly saying only use the following tables. And here I kind of just generated an explain of all the tables and also the column names just so we can have even more context. This is like badly formatted, but the rest is just, this is just SQL explain. Great, so we're actually going to import this SQL prefix and call it prefix equals SQL prefix. So we need to from .prefix import SQL prefix, and the prefix is SQL prefix .format, and we are going to, I'm going to paste this in, and we're going to import our boilerplates. So we imported boilerplates, and we're just going to format all of those into a string. I'm going to switch those. And look, I know there's a lot of stuff going on here, and these things we haven't covered yet. So I just want you to look at these for now. I hope the tutorial isn't too messy. It's kind of my first time doing a coding tutorial, so any feedback will be greatly appreciated so I can continue making better tutorials and help teach you guys more effectively. So here, there's a very nice method for the SQL database, which you can get usable table names, where it's basically just going to generate a string concatenation of all the tables available to the user accessing the database. And remember, we are here saying you only have access to the following tables, table names, which we're piping in there. And then we also print out, the explain here, mainly for the columns to be added here. So, but we also have a backup, which is great. Always be super explicit is kind of the name of the game here. Great. So again, we're going to ignore these for now and continue writing our app. Now we're going to put this in a system message. Oops. Equals system message. And the content is our prefix. And we're going to import it from LangChain core.messages import system message. We're also going to import human message, which we'll cover in just a second. Basically, the system message is usually passed in as the first of a sequence of input messages. So kind of like the template for the whole program to run off of. That's all you need to know about the system message. The human message is the prompt, essentially. We're just putting this into a nice class for LangChain to accept it in. Great, so now we're ready for answering our prompts. So we'll create a function called process question. We'll put in the prompted question, and we'll put the prompt to be the prompted question, and put content to be an empty array, sorry. And actually, before you continue, we need to set up our agent. So here from LangGraph, which is another dependency we installed, we're going to import create React agent. And we'll call this agent executor. And this is create React agent LLM, and tools, which we'll define soon, messages modifier equals system message. So here we pipe in our SQL prefix. Great. And as for our tools, and to set up our tools, for now we just need the SQL database tools. So there's actually a helper class here called SQL database toolkit, and we will pipe our DB into that and also our LLM, and it will give us the tool, actually the toolkit that we need. And from there we can derive our tools from toolkit.getTools. So it's just a nice little helper method. And we also need to import from LangChain community.agent toolkits, import SQL database toolkits. There we go. Great. So now let's start answering the question. So for S in agent executor.stream, this is a really cool method because here we're going to be streaming the response. You know how when you talk to ChatGPT and it's streaming the response to you, it has that nice little typewriting effect. Well, that's essentially what we're doing here. So we can get the data as it's being produced by the LLM, which honestly in this iteration of CondoGPT is not really a feature due to the front end. That's an issue that's on the repo. So if you want to start building your portfolio in AI engineering, you can check out the repo, look at the issues there, and make some contributions such as to this issue. Build up your portfolio with working with AI tools. So messages, we're going to pass in an array with human message content equals our prompt colon here, and let's do for message in s.get agent default that to an array if nothing's there, .get messages print message.content. I'm going to go through this code pretty soon. So let's try to process question and say what day is it, just to make sure it's working. So it seems I can't import this way. I need to drop the periods here. Let's actually try what was the most recent sale in the database. So now that we have that cleared up, let's just actually use a real estate question. What is the most recent sale in the database? Great. So the most recent sale in the database was for a price of $275K. Closing day of June 13th. Condo unit associated with this was, and there we get the ID. Okay, so it works. We can actually talk to an SQL database with plain text commands. Honestly, I'm fascinated by how simple it is to set up a way to communicate with an SQL database with just plain text commands. It literally just takes a couple lines of codes, and you can probably imagine the impact that this will have on interacting with SQL databases and allowing users to do that without any programming experience. That's why AI engineering and working with LLMs is going to be such a huge industry in the future. And that's why it's so great for you to start building your AI engineering portfolio and experience right now. Because right now is the best way to get an AI engineering role, because these tools are still so new. Many companies are not expecting a lot of formal work experience with them, little to none actually. The ones I've been interviewing with, they said that they don't require formal work experience with like LangChain and LLMs because it's just so new. On this channel, I share my journey as a self-taught AI engineer, and I'm going to be covering a lot of AI engineering topics. So if you're interested in that, make sure to like this video so I know you like the content. Subscribe for the new videos and leave a comment on what you'd like to see more of and what you're interested in learning. So basically in this iteration, we're getting the messages in the agent executor stream, which sometimes it could contain an agent, sometimes it doesn't. That's why we have this here. Sometimes it contains like other, system stuff that honestly is not really relevant for the application and definitely not something you want to print out on the front end. That's why we use this dynamic get lookup here. And yeah, that's essentially it. Let's actually work on the front end right now, because it will be so much easier to visualize then. So here we're going to import from Flask, import Flask, render template, request, session, and from main, we're going to import process question, because that's the main function that we're trying to call here. And we're just going to do some initial Flask setup. If you've never worked with Flask before, it's the easiest way to make your Python code into a web app, which you can serve on a web server or locally. For this purpose, it's nice because you can write your GUI with HTML and CSS, which is nice because writing it in Qt or any other weird Python software for writing GUIs is, last time I tried it, is like a horrible development experience. And also the web is the future. So like, I mean, who really installs programs on their computers anymore anyways? Boomer. We initialized Flask and we're going to give it the secret key, which is just a requirement you need for security purposes. Remember the secret Flask key we set up in our environment? Yep. Flask secret. There we go. Of course, we need to import OS to do that. And let's start with writing our routes. So we're going to use the app.routes decorator here. Oops. So here we put it to /, which is the index page. Here we allow the methods that can be used. And for now, we're just going to use get, right? So a GET request in web development is basically, you know, when you're loading a web page, that's a GET request. You're getting information, right? And then there's post, which is when you're posting information. Usually you're creating an instance or something like that. And then we define the index page here. We just call it index for, you know, easier to read purposes. And let's return render template index.html. And here, this is just some Python stuff. You need to basically write this. These 2 lines are just to make sure you can execute this file to run the server. And we also need to create our template. So the way this works in Flask, you create a templates folder, and here you create your index.html. Okay, so I just pasted a minimal version of the index.html from the repo. I'm not trying to teach you HTML in this series, so I'm trying to keep it just to the AI stuff here. Basically, we're going to pipe it a result variable, which is the result, the answer to the prompt, right? Which we reiterate on top of because it's going to be in an array. And we're going to implement conversation history, so you'll still have the question that you prompted it next to the answer. And of course, you know, a nice little form here to submit. And it looks like we have a error here. 1 colon too many. So as promised, we need to pipe in a result here, and the result is going to come from process question. And we're going to say, what is the oldest sale in the database? And so let's try to run our Flask program now. So Python server.py to run it. Here you'll get the local URL where it's hosted. And great, it loaded our template. I actually made a mistake here because we're supposed to send the question through a post request. So we're going to allow that method here. And the result, we didn't get there yet because we need to write a function for it. If request.method equals to post, so if we submitted the form, right? That's when we want to get the actual question or prompt that was asked. So we'll get question equals to request.form. No, there we go, question. And then results will come from process question. And we need to set a default for the result, which will be none. Let's try this again. What is the oldest sale in the database? Let's submit that. Let it do its thing. And it seems we're getting it in the terminal here. Yeah, because so here we have the message content. We need to append this into our content array. because we're just printing out to the terminal now. So of course we're not going to get anything back. And then we return content. And because content is an array, remember, that's why we are iterating over result here. So let's try this again. What is the oldest sale in the database? Great. So the oldest sale in the database occurred on May 1st, 1971 with a sale price of 17,000. Okay, great. So let's implement conversation history now. You know, when you talk to ChatGPT, it will remember your previous prompts up to a certain limit. This is not something that can be achieved with the OpenAI API, so you have to manage your own conversation history. But it's easy. Let me show you. So we have to go to our main.py, and we're going to pipe in a conversation history here, which will be an array. And let's write a context and call it, we're going to use a carriage return here to join. Let's see, make this a little bit more readable here. And this can be a bit crazy looking, but so here we have the question, right? And here we have entry, question, another carriage return, and then an A for answer. And then here we'll put entry, answer. So we're going to feed the entries with both answer and questions in a dictionary, right? And this we're doing for entry in conversation history. So we're looping over the conversation history. The conversation history would be an array of dictionaries with a question key and an answer key. And I seem to have misplaced so I just pasted it from the repo and fixed whatever syntax error that was. I just couldn't really find it, but it's definitely something minimal. Moving on, we want to create our consolidated prompt. And this is again an F string. And we're going to make it like this so we can do a multi-line F string here. I'll put previous conversation, pipe in context. And here is the new question. Prompted question. Please answer the new question, taking into account the context from the previous conversation if relevant. And here the prompt will be actually our consolidated prompt if we have a conversation history, else prompted question. Okay, so what are we doing here? We're feeding an array called conversation history that has the previous question and the previous answer. We're basically generating that into an entire string. We're piping this into this template. So every time we're prompting the LLM here, if we have conversation history, when we're going to tell it, hey, this is the previous conversation, this is the new question, answer the new question by taking into account the context from the last. But we have to submit this on every prompt, which means that every prompt, every call to the OpenAI API is going to contain the conversation history and this little template. And one of the problems with AI engineering is token management, because you have a certain cost per tokens that you send to the API. And you don't want to send a long conversation history and really exceed your limits and basically get overdraft fees on your mom's credit card. So that's why we need to put a limit on the conversation history. Now, I actually like doing this in the server.py. So I'm going to put max content length equals to 5. No, 3 actually. So this is the number of previous conversations that we keep sending in each request. So we need to write a handler for the conversation history, right? And for this, we're going to use Flask sessions, which we can store stuff like your conversation history in the browser, like with cookies and all that. And it's super simple. Basically, we'll do if user ID not in session, we're going to do session user ID equals the string UUID4, and we need to import some stuff here. So it's from UUID import UUID4. UUID4 we're just using to generate a random string, a random identifier for whatever user is currently using our web app. In a production environment, you would do something more sophisticated. You would have a login system and all that. We're not that fancy here. And session we already imported. And while we're here, we actually, in our template, we have a sort of sign out button. So let's just add some code to handle that. So if the form has the sign out attributes, then we are going to clear our session. So we clear the conversation history. And we also need to return the base HTML template. Index.html result equals result, because we want to kind of refresh the page, right? So let's add a get conversation history handler here. Super simple. So if conversation history is not in session, if we haven't stored any conversation history, well, big surprise, we're going to store that conversation history here. Yeet equals to an array, and then we return session conversation history. So basically, if we don't have conversation history in the session, we're just going to initialize it as an empty array so that we can append stuff to it without stuff crashing. And let's add the method for adding to conversation history. And here we need the question and the answer. And then here we're going to load our history with get conversation history, if we have some, and then append question will be question, and then answer will be answer. And you'll recognize this format from what we did in main.py. So here we have the entry, question, entry, answer. It's the same thing. And that's what we're setting here. And here, if the length of history is greater than the max content length, well, that's when we pop the oldest history. So we're removing the first conversation from the conversation history here. Session conversation history equals history. And then we set the conversation history in the browser to this. So after we load our question here, we're going to load our conversation history, which we'll get from get conversation history. And then after a result, we want to add to the conversation history the question along with the answer or the result that we got. And the result, we want to pipe in conversation history. Let's see if this works or if there's something we missed. So we forgot to remove this. What is the oldest sale in the database? Let's run that. What is the difference between $400,000 and the sale price of this sale? Let's see if it remembers. And here you go, the sale price of $17,000. So it did indeed remember the last answer that we got. And here it calculates the difference. Wow, really cool. I can perform basic arithmetic operations. AI is taking over the world. But the point is, it now has memory. So it's not just a stupid slave machine. It can actually remember stuff. Now, you may be wondering, how do I debug this application, right? So a lot of your problems are going to arise from incorrect SQL queries. So you need a way to easily analyze the queries, right? And for that, I have written a function for it, which I will write with you right now. So we're going to call it print SQL. This is just to kind of pretty print the SQL so it's more human readable. We use a print, multi-line string, and then the SQL query. I always put this because then I can easily control F to, the SQL query, pipe in this, and then .format SQL. There we go. Now let's go back to our process question, right? So so each message has certain tool calls, right? So we have different tools, right? Well, we cannot just have one right now, the SQL database tool, but we have something called tool calls. So for call and msg.tool calls, and here we're going to use something really gangster called the Walrus Operator. So basically, let me write this out first. So basically what we're doing two things here. We're retrieving this from a nested dictionary, right? And we're assigning that to this variable. And we're also checking that this variable is true. If it is true, well, then we already have the variable assigned, so we can basically do whatever we want with it. Otherwise, you would have to use two lines. You would have to put this code in its own variable called SQL, and then you have to say it if SQL, and then do this, right? That's why the Walrus Operator is just so gangster, and you should use it whenever you can to really flex on your boss or whoever else is checking your code. And now we're going to use our pretty print function called print SQL, and we pipe in SQL here. Let's see. What is the average holding period for 2 bedrooms? We're not going to use Brickle because Brickle is not part of this database. We'll just do generally like this. Okay, so finally executed in just a millisecond because that's how fast my code runs, and any bottleneck is the OpenAI API. And look at that, we have the SQL code printed here beautifully. And if you remember, it looks pretty much essentially the same as the boilerplate I provided for the holding periods, with sale deltas as random SQL code, with sale deltas. Here you go. So this is a great way for you to debug your application, make sure the proper SQL queries are being used. And if they aren't, you can see where it's going wrong. You can specify the exact SQL queries that you want to execute as a boilerplate so that the application knows more specifically what it's supposed to query about. It's kind of like teaching a toddler how to open a fridge door. You can't just assume it's going to know to put the hand on the handle and pull it out. Like, you kind of just got to spoon-feed information until eventually it's like, oh, wow, I should use my hand to open the fridge door. And honestly, I'm just going to leave this here because we don't really use the terminal anymore anyways. We have the front end. So I'm going to keep the SQL being printed here. All right, so now let's expand on the functionalities a little bit. I'm going to bring up the mind map that I created in the last video where I scoped out the design and the architecture of this project. If you haven't watched that video already, I highly implore you to go watch it because the technique I used is extremely useful. It can save you so much in development time. It can help you get promoted at work, can make you really shine in your office, essentially. Most importantly, I'm going to reference it as I'm developing now, which is going to make things a lot easier, especially for you to understand. So we have the LLM, right? And we connected it to the front end. And let's implement these features, right? So, for example, we can check against incorrect spelling of the names in the database. For example, if you ask, what is the address of the Alexander? There's a building in the database called the Alexander. But now it's going to query. Let's see. It's querying where alt name is Axelander, and there is nothing in the database called Axelander. But notice, if I clear the memory, so I'm resetting the session, right? Removing the conversation history. What is the address of the Alexander? And it returns the correct address. So how can we make an application like ChatGPT that can sort of notice when you're making spelling mistakes and still retrieve the correct address or the correct name of a building? Well, this is where vector databases come into play, and this is super interesting stuff. So what we're going to do is we're going to vectorize all the addresses and all the names of the buildings in the database. That way, whenever we prompt and the LLM notices a part of the prompt could be a building name or a building address, it's going to use similarity search to find the most similar building name or address in the database. And to be able to do this, we need to vectorize the data, which we're essentially creating a mathematical representation of the addresses and the names so that you can plot them out in a sort of graph and calculate I'm not sure if this is Euclidean distance. I think it is the Euclidean distance between the 2 points. One point being the actual name of the building, the Alexander. The other point being Te Axelander, or whatever misspelled garbage you feed into the front end. And this is a great way of learning the importance of vector databases because they have so many more applications than this. So for this, I'm going to create a tools.py, and we're going to start putting our tools in here, right? So I'll make a function called def setup tools, and we need DB and LLM here. And first of all, we're going to get all the addresses from the database. Now, for this, we actually need to write another utility function. I call this query as list. And we need a DB here and our query. So basically, we're going to feed an SQL query that looks something like this. Select address from core condo building. So we basically selecting the entire column of addresses from the building. So we're getting all the addresses, right? But and here we basically just want to clean it up. So we'll have result equals db.run this query that we're feeding it. And actually, I think the best way of explaining this to you is to show it to you in action. So we're going to call this tool, and I'm just going to put a Python breakpoint here. And a main.py, we're just going to, here we'll just put setup tools on your DB and our LLM, right? And let's see, from tools, import setup tools. And that should hit our breakpoint. We need a DB, the LLM. Oh, we didn't feed the DB here. Great. So let's see the results. So basically, when we look at the response here, you'll see we have an array, or actually a string of an array of tuples. And we need the first element of each tuple. So I'm going to break out of that. So first we're going to import something called abstract syntax trees, or AST, because we will get our names list by running ast.literal evaluation of result. It basically converts this string of a list into a pure list. And it also escapes some malicious code, which is great because never trust the LLM guys. It can always spit out malicious code, or whoever is a user using your LLM application, they can prompt the LLM to return malicious code. You always want to put up your safeguards. So actually, when we get the names list, we just need to return them, and then we're done here. And we can do the same for the alt names. So each building, some of them actually have another name. So for example, the Alexander would be one. For the Alexander, this is the alt name, and this is the address. So we want to get both of them, right? And build our vector DB with it. So this is the name of the column for alt name. Same thing there, we're querying as list. We're getting basically a list of all the different ways you can address a building. Now we'll create our vector DB using FAISS. Which we will import from LangChain community dot vector stores import FAISS from, and it has a nice utility function called from texts, and here we concatenate the addresses with the alt names, and we will use the OpenAI embeddings, initialize that. And this is from LangChain OpenAI import OpenAI embeddings. There we go. So we're using, effectively what we're doing here is, we're taking all of these strings, right? these lists of strings, and we're initializing a vector database with FAISS, which is Facebook AI Similarity Search. Basically, you use this for similarity search, like finding the distance between vectors and all that, but you can also initialize a vector database. This is going to live in memory, but if you have a lot of data to feed into a vector database, it makes more sense to use something like Chroma, which is something that I believe it's stored on the disk rather than memory, because a computer only has so much memory. And we're using OpenAI embeddings. The embeddings are what's used to convert the strings into a mathematical representation so that we can plot them in this graph, right, and get the distance between the prompted address and the addresses in our database. I hope that explanation makes sense. If not, then please leave a comment and I'd love to clarify. There's also a lot of good videos out there on vector databases from people that can explain it a lot better than I do. So here we need to define a retriever called vectordb.asRetriever, and here we'll do search quargs equals to k5. The quarg k equals 5 means we'll return the 5 most similar results to the query. Our description will be used to look up values to filter on. Input is an approximate spelling of the proper noun. Output is valid proper nouns. Use the noun most similar to the search. Here we're treating the addresses and the names of the buildings as proper nouns, because that's basically how we define it in prefix.py. Proper, no. Here, if you need a filter on a proper noun, you must always look up the filter value using the search proper nouns tool, which we're about to define. Do not try to guess at the proper name. Use this function to find similar ones. Basically here we're telling you, hey, if the prompt contains some proper noun, like a building name or an address, use this function to find the actual proper noun. And now we create the retriever tool. And we need to import from LangChain.agents.agents toolkits, import create retriever tool. And that's how we do that. Here we feed it our retriever, and the name of the tool, this is very important, search proper nouns. And we'll feed it the description. So remember how search proper nouns is the exact same thing that I called in prefix.py. Always use the search proper nouns tool. So that's how the LLM can use the prefix to look up the correct tool to use. And the description is also very important so that the LLM kind of knows what the tool is and how to use it. And we're going to fix this retriever tool. Okay, great, but we still need to add this to our tools in our agents. Going back to our main.py, actually take these tools out of here and move them into the tool section, the setup tools here. So toolkit is SQL database toolkit, which we need to import. And then we'll do tools.append because this tools is an array, retriever tool, return tools. And here we'll do tools equals to setup tools and db LLM like that. We have setup tools already there. Let's try this out. So it seemed like I have an error because we still have tuples here, so we're just going to reference the 0th index here, and that's how we solve that problem. Let's try run again. Oh, now I'm running tools.py. No, server.py is what we want. So let's check it out. What is the address of the building Axelander? So we misspelled Alexander here, the Alexander. And look at that, it still finds the Alexander. This is great. We've learned about vector databases, embeddings, creating our own LangChain tools, and improved the app significantly and the user experience because when you're using ChatGPT, these LLM tools, you're doing a lot of typing. So like you get lazy, you kind of know you're typing a typo, but you want to go back and fix it. You kind of just hoping the LLM just notices, and more often than not, ChatGPT catches it and they fix it. And this is how it works. I hope I've been able to show you how it works, because the technology behind it is just super interesting and something I'm very passionate to learn more about. So at this point, this whole branch is done. Let's give it a nice blue color here. Bam. At this point, you can see that you can prompt the software to analyze the data and make these mathematical operations to analyze it on the fly. For example, you can prompt it, what are the top selling buildings in 2023 on this particular street, like Collins Ave. And it does that for you, sorts it for you, which is excellent. But data is a bit jumbled like that. It's kind of hard to read. It would be nice to be put in a table, and it would be nice to be able to visualize it with a chart, right? That's the next step. So Frontend connects to Flask. Here, data visualization and charts. Now you'll notice in our prefix, this is the language I've added here. If a prompt asks to generate a graph or a chart, generate the HTML code for a graph with the Chart.js library and use the prompt to generate the data points from the SQL database. Exclude the script tag for Chart.js as it is not necessary. Important, just provide the HTML. No explanation is needed because these LLMs like need validation so badly. They need to yap about what a good work they did every time they spit out some answer to your prompt. So you have to really tell it to shut up sometimes. So let's see this in action. Generate a graph of this data. And notice I include the language for generate a chart and generate a graph. So you can use both interchangeably. But look at this, you're getting HTML code. Not only that, it's wrapped in Markdown. This sucks. I want to render it. So let's do that. First, we're going to go to our index.html. And here in the head tag, I'm going to paste this script, which is basically the Chart.js library that we're initializing. But this is not enough because, as you can see, there's no way for the program to determine whether this is code that should be rendered or text that should be displayed to the user. So let's fix that. And here we need another utility function called extract and remove HTML. And we're going to pipe in the text here. And we're going to pass in the text we get from our response, right? So here when we get the message content, we actually, before appending, we are going to get the HTML and the stripped text from extract and remove HTML. And here we pass in message content. So the response gets into this function. And here we clean it up. So here is a regex pattern for identifying HTML code that's wrapped in markup, which is how ChatGPT will give you HTML code. And here we'll do match equals read the search, HTML pattern, text, and we're going to ignore the case here. Also need to import regular expressions. And an if match, we have HTML code, and we basically group them. This is just regex stuff right here. And this is just how we get the HTML code here. I used regex 101 to kind of get to this solution. Nothing crazy here, just like boring regex that I don't want to talk about, honestly. If you're one of those weird people that likes writing regex, then you're probably on an FBI watch list. Remember how I told the LLM not to yap and give an explanation behind the charts and the graphs? Well, guess what? It's still going to do that sometimes. So let's try to clean up the explanations as well. So and we also want to return the text without HTML. Rela sub HTML pattern text flags equals red, ignore case. And then we're going to strip this. And we want to return it into markup, actually. So cleaned HTML in markup, text without HTML. And we're wrapping this in markup to prevent escaping. HTML can contain stuff like slashes, backslashes, which in Python strings can be escaped, So we're just going to start wrapping everything in markup to make sure we don't escape anything and to make sure everything that's spat out of our process question function, everything that's spat out into the front end essentially is in markup and just in the same format. It makes it a lot easier when you always expect everything to be in markup. And this class comes from a library called markup safe, which is apparently not installed. Yes, it is. It's just my VS Code tripping. And of course, if no HTML is found, we're just going to return none. And the text should be here. No, actually, HTML code. There. Sorry about that. So we have our HTML here and then our strip text. So we need another function here called process markdown. Basically we're taking the pure text response from the LLM, so no HTML code or anything. We're converting it into HTML, and then we're wrapping that in markup as well. So again, we're standardizing the output. No matter what we have, it's always going to be a string or code or whatever that's going to be in HTML code, and that's going to be wrapped into markup, just making things a lot more easier. And sneakily, I'm going to import the markdown library. Don't tell anyone. Okay, are we done yet? Can we display some charts already? We're almost there. So the message content we can still print. That's fine. Nobody's going to sue us for that. But when we append this, we need to process markdown and make sure it's wrapped in markdown and HTML like it should be. And if we have HTML, then we can just append the HTML, because remember, the HTML we have already parsed. The HTML is the HTML code wrapped in markdown, so we don't need to process it anymore. But here we're making sure that if there is a useful explanation that we want to display that comes with the charts, well, we're still adding that, we're still wrapping that in HTML and markup, but also we're adding the HTML code as well. And of course, I forgot to import this. That's why there's an error. Silly me. So let's just ask this basic question, get some data in the conversation history, and then try to generate a chart. As you can see, it's already being spat out in a much nicer way because we have some CSS formatting and all that, and it's being spat out in HTML format, which is great. This is also another reason we wrap all the text in HTML. It's just much nicer to display on the front end. Generate a graph of this data. Okay, so we got the HTML code and also the chart. Look at how nice this chart is. Wow, beautiful. But for some reason we get the explanation as well, so we probably made a mistake somewhere. I'm guessing we're adding multiple times content app message. Right, so we're adding the message content, which we don't want because we cleaned up the message content. We want the stripped text only to be displayed. Silly me. Bam, that's what I'm talking about right there. So basically you can generate any data and then ask it to spit out a nice looking chart here, interactive as well, so you can easily and quickly visualize the data, which is super useful when you're dealing with people who are not very technical, right? So this is awesome. I love this. Let's move on. Next step, generate maps. Since we're dealing with location data, we might as well integrate the Google Maps API. And as I'm filming this, it's Halloween, so that's why it's becoming more and more darker and spookier the longer the tutorial goes. I'm on like the 3rd hour of recording this tutorial, so like I feel my sanity dropping as well. So let's start with the prefix. Again, I'm not going to write this out because it's already here. Basically, if prompted to generate a map, use Google Maps. Do not generate any script tags for the map because we're going to define it in our template ourselves. It will still sometimes generate the script tag. Only generate the HTML code for the map. When generating a map or graph, only return the HTML code required. Do not include any additional text, explanations, or descriptions. We don't need an explanation about the map. The map should be self-explanatory. And also, when generating a map with markers for buildings and schools, this is another one of those like specific features that I've added. So basically, there's latitude and longitude columns. So use that to generate a marker with a Google Maps API. And for schools, use the Google Places API to find them. And then use geocoding tool, which we're going to write as well to get the latitude and the longitude of the schools. And so we can calculate the distance. And here we have some boilerplates for marker generation. This is just JavaScript code. Yeah, this is the format we want the markers to be in. Here is how the boilerplate for the initMap function should look like. So how to initialize the map. This is just basically how it should always look like. Yeah, generate a JavaScript function named initMap using the boilerplate, which we add here. And ensure that the div contains the ID equals map for the map to render properly. Great. Now let's go back to our tools. Just to recap here, the LLM already knows how to produce the code to generate the map at this point. We just need to make sure it knows, for example, how to generate the markers for the map using the SQL database or the external data sources that we provided. Those are the tools that we're writing right now. So at the top here, we're going to define Google Places equals to Google Places tool. Again, the Google Places tool is used to calculate distance and retrieve things such as schools and all that. Honestly, it's like Google Maps on steroids. From Google Maps, import client as Google Maps, and from LangChain community.tools, import Go Places tool. This one goes up here. Bam. So let's first start with the geocoding function. Geocoding is taking an address and retrieving the coordinates for that address. So geocoding tool, we are going to import base tool here from LangChain. From LangChain.tools, import base tool. So we can easily write our own tools here. And we need to give it a name called Google Maps Geocoding. This is the name we need to reference in the prefix.py. Description equals to useful for converting addresses into geographic coordinates. And then we need to give it a input schema. So we call this directions input. This we write ourselves. Directions input. And we need to import something called a base model. Import some stuff from Pydantic. From Pydantic, import base model field. So we need to define origin here. Equals to string and then field. Spread that. Description equals to the starting point address or coordinates. And destination, again, string, field. The destination point or coordinates. And honestly, I used type hinting here from Pydantic because that's how it looked like in the LangChain documentation. I haven't really delved into the actual structure here of how to set this up, I think it's a bit weird, different compared to the other things I've shown. The bottom line is it's not really important to understand this. If anyone wants to give me more detailed explanation, then feel free to do so in the comments below. When I was building this, I just wanted to hit the ground running and not really. So that's why. So I got honestly lazy at understanding this part, but it's just a little input really. And every tool needs a run function. So we have self address here. Let's try. And here we get the geocoding results from Google Maps. I just realized we did not import Google Maps. Actually, we need to define it. Google Maps, os.get environment, gplaces, API key, because they're pretty much the same. Oops. So let's import os. And then we do gmaps.geocode. So if we have a geocode result, location equals to geocode result. This is just how it's structured, the actual coordinates, and that's how you retrieve them from the result. I believe it's in JSON. And I like adding a print here, and then geocoding tool, and then print address, print location, geocoding tool. And this is just nice for debugging purposes, because I did have a lot of problems before with making sure I got the correct coordinates. And then we return this into a human, or rather LLM readable string. So the coordinates for the address are location lat and location lng. So this tool is going to spit out this sentence to the LLM. The LLM, or rather the agent, is going to use this string to determine, okay, these are the coordinates. Now what do I do with them? Okay, well, I got these instructions. I have access to these tools. This is what I'm going to do. Now, if we don't have a geocode result, we're just going to tell the agent unable to find coordinates for the specified address. And then we need to have an exception as E. I'm not catching a general exception here really, because I want to print out to the console. So an error occurred while fetching coordinates. And then here we will display the error. Okay, just one more tool to set up now. Bear with me. So we set up the directions tool. This is so we can find pretty much distances between different locations. So we'll call this Google Maps directions. Again, the name is how you should reference it in the prefix. Be very clear about that. Useful for finding travel distances and directions between two locations. And our arg schema, we're going to use directions input. I think I made a mistake here. I think we don't need to supply the directions input to the geocoding tool. It makes no sense. It's origin and destination, and that has to do with the directions tool. So I'm actually going to move this yonder. Beautiful. And here every tool needs a run function. So self origin destination is what we pipe into it. And we're going to try, and same thing here, directions API, just for debugging purposes. Origin destination directions result equals to gmaps.direction origin destination, and then we'll do the driving distance. This you can make dynamic, of course. You can make it walking distance, or like determined by whatever the prompt is, that's beyond the scope of this. Maybe that's something you want to implement yourself on the GitHub. And if we get directions result, distance equals to directions result, and this is how it's structured. We get legs because the Americans were not pleased enough with using feet to measure distance. No, it has nothing to do with that, actually. Just some little European humor for you there. Here we get the duration as a text. And here we return an f string with the travel distance from origin to destination is distance, and it takes approximately duration by car. Beautiful. If we don't get any results, we'll just say unable to find directions between the specified locations. You always want to return something human readable from your LangChain tools, because this is going to your LLM. If you just give it a bunch of errors, it can cause some issues. It's better to kind of just assume you're talking to a human being, and that way it's a lot easier to work with. So again, catch a general exception. I know, illegal, but whatever. An error occurred while fetching directions string E. Okay, now let's finally initialize our tools. So we got the directions tool equals directions, not input, no. And the Google Maps geocoding will be the geocoding tool. And here we will append both of them. So Google Maps geocoding and directions tool. Right. So because, so we basically just need to switch up the quotation marks here. Since we have double quotes here on the inside, we need to have single quotes on the outside. Alright guys, sorry about that. I had to fix some errors. So first of all, we never added the Google Places tool. And this is what you need to look up things like schools near this address. And we never added it, so of course we weren't accessing the Google Places API essentially, so there's no way we could retrieve the schools. Another fix I saw is this query as list. This is kind of an optional fix, but I think it makes sense. I rewrote it and added this regex here. Basically removes the digits from the string. So this is, for example, if you misspell 150 Northeast 2nd Avenue, it's going to check for misspelling in 2nd or ND and Avenue and find similarities there. Because if you get the number wrong, then maybe you're not looking at maybe you're trying to search for an apartment or a building that doesn't really exist. This is kind of like a personal choice. I feel like it makes more sense. So that's why I added this quick regex in here. I know you can probably rewrite this to be in, one more for loop to make it more performant, but that's how it is. So I'm removing this query as list. Again, you can keep it if you want, if it makes more sense. I have my reasons for deleting it. But this is the Google Places tool that we just defined and then never included in our application. So whenever you're writing your tools, make sure to add them to your tools and feed them to your agent. Otherwise, you're not going to be able to use them. Duh. So I'm going to load the app, clear the memory, load this prompt again while buildings on columns had the highest number of sales in 2023. And what we can do is we can ask to put it into an HTML table, make it a bit more easier to understand. This is, again, the power of using HTML wrapped in markdown, markup. And then let's add another column with the closest school to each building and another column with the driving distance between the building and that school. And here you go. We successfully added 2 columns with the closest school and the driving distance. And it even included the time to drive. That's nice. And again, this is using the same API as when you use Google Maps to drive around. So, some routes can be more trafficked. Some routes, even though they may be shorter distance, may take longer due to a lot of turning or a lot of traffic, essentially. So this is just really useful, especially in the context of building a real estate AI agent. Let's see if we can generate a Google map now. To do this, we need to go to our index.html and we're going to load a Google Maps API script. Now notice here, key is brackets gmaps API key. Since Flask uses Jinja 2 to serve HTML templates, this is Jinja this is basically like an F string in Jinja. So we're going to pass in this variable from Python into HTML. So go to server.py, and here we're going to paste in gmaps API key equals os.get-env places API key. It's the same one. And save that. Going to restart the server just to make sure. Sometimes the changes won't really run unless you restart the server, I've found. Make sure you clear the memory too, just to make sure. And we'll start the sequence all over again. Okay, the moment of truth. Let's generate a Google map with markers for each building and each school. Awesome. So it might be a bit hard to read, but the markers are indeed generated and in the correct spot. So for example, South Point Elementary School, 1054th Street. It's right here. Okay, maybe it's on the wrong side of the road, but I think that's good enough for our purposes. Same thing with the Alexander is right here where it should be. I'm very happy with this. You can make it a bit easier to read as well. You can expand on it. Hopefully by now you're able to see how powerful AI engineering can be and creating these LLM-driven applications. You can query a geospatial database and easily generate Google Maps of the location data, aggregate that with financial data as well, and just combine everything in one extremely easy to use app. Because remember, the GUI is just a chatbot. And just with plain text English commands, you can do so much high-level analyses, produce reports and all that right at your fingertips. Speaking of which, we need to implement a PDF reporting feature. So let's do that. I'm going to reference the diagram again. Yeah, generate PDF reports. For this, we're going to use the one and only, the AK-47 of Python PDF reporting libraries, ReportLab. Not that I've used any others, honestly. So we're going to go to our main.py and check this out. We're going to import ReportLab. Actually, we're going to import Letter and Canvas, but we're not actually going to use them. You might get an error or a warning in your IDE saying, hey, you better use these variables, otherwise something bad's going to happen. Well, no, we're going to tell the LLM to use it and execute Python code for us. Stay tuned. So here we're trying to extract and remove HTML code. Well, what if we prompt the LLM to give us back Python code so we can execute it? Let's check that out right now. So here I have a pattern, a regex pattern for identifying Python code, and then a markdown pattern for the markdown prefix that ChatGPT delivers Python code in. And we're going to check both of those. So here we have two patterns. Basically, I've identified two patterns which OpenAI delivers Python code in. It can be this, I believe, HTML pattern or markdown pattern. And we're going to check both of these just to make sure, because there seems to be no consistency. At least when I was developing this application, I had to use both. So we're going to check either of these, whatever match it was. We'll wrap it in an if statement. I like printing it as well, just so I can see what Python commands are being executed. And we're going to group this, just do some basic regex stuff here. Here I'm just doing some conversions to make sure it's Pythonic. We're going to return none. And how about we just say PDF generated here. At this stage, if we're executing Python code, the only possible solution is we're generating a PDF. So let's output that to the front end. Of course, you want to make this dynamic in later. And then we're going to return the code. So we have a third return parameter now. So here we need to return none. Whenever we're not returning Python code, we're just going to return none. Actually, we'll do false to be even more explicit. Don't execute this code. Okay, so now extract and remove HTML, which is now not really well named. I know, a rare occurrence in the world of me naming variables. We're going to roll with it though. So we're having a third return, which is code. Again, really great naming. If code, execute code. Now hold on here, like hold your horses for 1 second. So here we're kind of just trusting the LLM that whatever Python code it spits out, we're going to execute on our system. Python is a very powerful language and you can do a lot of damage to your system. So you need to make sure you sanitize the code. Someone else uses your web app and they prompt the LLM, hey, generate some malicious Python code. Then your server is just like deleting a bunch of directories, or it can be very nasty. Now, I posted this as an issue on the GitHub, and one of my subscribers actually came up with a pretty nice solution. So shout out to Lucifer Akirami, passionate programmer in the world of AI. Yeah, good job, man. Good job. So we're going to use his solution, or hers, what they, them, whatever, Lucifer. So I'm just going to gently borrow his code, hers, whatever. He's regexing a bunch of like nasty functions and libraries being imported. So I believe with this, there's still a chance to generate malicious code, but at least this reduces the chances by a lot. So huge shout out to that. So before we execute the code, we are going to detect malicious code. There we go. We're going to execute that code. So put the data back into an HTML table. Can't access the local variable code match where it's not assigned with a value. Yeah, so this should be MD match, of course. Silly me. Maybe we can. Okay, so I prompted it to get back to where we were before, and then let's generate a PDF report with this data. PDF generated, and sure enough, we have something called CondoSalesReport.pdf. And look at that. I mean, it doesn't really fit perfectly on the page, which is also an issue on GitHub that you can solve and contribute and build your AI portfolio. But it looks nice. I'm happy with it, honestly. Like, this is already a very useful tool in the context of a real estate agent. Now we finally arrived at CondoGPT as is written today, according to the video that you all liked so much. And if you made it all the way to the end of this tutorial, like, wow, please let me know, because I'd be surprised to find out anyone made it through all my rambling and stuff. It's my first tutorial and my first video this length. So yeah, please make yourself known in the comment section. And I'd love to make another video about taking this to the next steps and actually creating a full AI real estate agent with image and video generation technologies, knowledge-based creation, data augmentation, document analyses, and more advanced similarity search features. So if you want to learn how to take this to the next level, you want a tutorial on this, please like the video. Please comment below saying that that's what you would like to do. Honestly, these tutorials take a long time, so if there's not really a lot of interest for that, I have other video ideas I'd rather get to. So once again, thank you so much for watching. It's been a pleasure, and I'll see you later.